If you use a lathe, at some point you'll have to hold onto a part by that perfectly turned surface you just made. Obviously you don't want to dent or scratch that finely honed finish, so grabbing the part right in the hardened chuck jaws is no bueno, amigo. Most would just wrap the jaw faces in some soft aluminum, as I usually do. But this is like wearing your Speedo to a lumberjacking competition. Technically you're covering the important bits, but one lapse in attention and you could seriously damage your rod. Okay, maybe that's a bit of a stretch, but this is super janky. There has to be a better way to protect one's parts. So today, I'm in search of a more robust softjaw solution. Where to begin? Well, how about some requirements? Other than just generally making softjaws that are less nausea-inducing, I do actually have some legitimate grounds for improvement. For one, these aluminum covers have some twangy bits that, other than striking a nice tune, regularly surprise me when they snag on a rat's nest of stringy chips. So I want to streamline mine a bit, with no extraneous edges to catch on unsuspecting swarf. The next concern is the soft component of these softjaws. Obviously, they need to be softer than the material they're holding, but if I'm already holding a soft material, then I need something even softer. To solve this, I think I'll make the clamping elements of the jaws interchangeable. This way, I can use aluminum on steel parts, copper on aluminum parts, plastic on copper parts, and jello on, well, I don't know what I would use that on, but the point is, I could do it. This also gives me the option to replace the elements as they wear out. The last requirement is actually more of a compromise. I have both 3 and 4 jaw chucks, and their jawmetries are pretty different. This makes it hard to design something compatible for both. But 99% of the time I remount a part, I switch to the 4 jaw anyway for alignment purposes. So I'm just going to focus on making a set for the 4 jaw chuck. Okay, that's enough talking and pointing. Let's flesh out the details. To make the gripping elements simple and interchangeable, I'm just going to go with round pins, which I'll make a light press fit into the body of the jaw. This way, I don't have to worry about cramming additional mounting hardware in such a small space. The hollow in the body will need some clearance for the corners of the jaw tips. And on the back side is an integrated tab which will protect the jaw faces from the set screw I'll use to secure these in place. I'm also going to leave the outward facing side covered, which should help with the annoying chip grabbage I mentioned earlier. And in the name of reducing grabby bits, it won't hurt to put rounds on basically every corner and edge that I can. I've got just the tool in mind for these, and I've been itching to put it to use. Okay, that should do it. And with just one major component to worry about, okay, well, maybe 4, these should be a walk in the park compared to most of my builds. The vast majority of these jaws don't actually need to be soft at all. So I'll make the main bodies out of a more durable low-carbon steel. Ironically, of all the operations that go into a part, the most time-consuming by far is just getting the stock to size and square. Multiply that by 4, and you've got a real task on your hands. But I'm going to take a slightly different approach this time that should save me a few minutes in the end. Rather than continue to cut this down into 4 smaller blocks, I'm going to head over to the mill early and square this whole thing up first. This should drastically cut down on the number of faces I need to mill. The first face is pretty wide though, so I'll need to bust out the heavy artillery. My massive fly cutter. I don't need the full swing, so I'll adjust the cutter head in as well as the counterweight on the other side. And with the insert looking nice and sharp, we're ready to go. Yup, that never gets old. I'll work through the 4 perimeter faces with a smaller fly cutter, using a precision square as needed, and always making sure to keep that first milled face against the fixed jaw so everything stays square. Except for this one apparently. Bro dude, what the heck. You gotta love it when you don't catch something till the edit. Anyway, this leaves the final face, but it needs a little extra work first. I need to remove a good portion of this thickness, and while I love using my big fly cutter, this could take all day. So I'll settle for some equally satisfying roughing milling. Rough milling. Roughing mill. Basically, we're just going to hog away a bunch of the material. Okay, maybe taking such a honkin' wide cut was a bit ambitious. I have to run the feed super slow just to keep everything from chattering like a mofo. I mean, it works, but this first pass took over 5 minutes. Not exactly the speed I was looking for. Let me try that again with a shallower engagement, somewhere around half the tool diameter. That is way better. This feeds so much faster before chatter is a problem. I suppose this makes sense given that I'm only cutting on one side of the end mill. So all the cutting forces are going the same way, rather than constantly bouncing from one direction to the other. And while I'm only taking half the cutter width on each pass, these only take a little over a minute each. So basically, I'm removing material at twice the speed. Pretty counterintuitive, but hey, the proof is in the power feed. With that milled down within striking distance, I'll switch back to the big fly cutter for the final cleanup. Alright, that's 6 faces. No, 16 faces of the 24 I needed to square up. I'll take one more trip to the bandsaw to cut these down, then come back to the mill and run through the last 2 sides on each block. Man, all that work just to make 4 stinking blocks. But they are very nice looking blocks, and more importantly, all the same size, which is going to help me a ton. So let's finally get to work on some of the finer details. I'm going to attempt to make all 4 of these simultaneously, which means I'll be bouncing from one part to the next with each setup. So this vice stop is literally going to be the cornerstone of my success. After zeroing on this corner, I'll begin on the insert mounting holes on the ends. First spot drilling, then cycling through each of the remaining blocks, before switching to a drill and running back through. Now I want these holes to be a precise diameter, but also guarantee they're square with the block. A challenge for drills and reamers, but no sweat for a boring head. So again, I'll start working through the blocks, opening up their bores little by little, making small adjustments to the head as I go. Now normally I would use snap gauges to check the diameter, but thanks to one of my awesome patrons, Eric, I now have a super nice set of gauge pins that will be even better suited for this task. So I'll work my way through the sizes until I find one that just barely fits. If I've done this right, I'd expect this to stop at 0.374. And it doesn't. Well, there goes the spec. Even more puzzling, the bore seems to be tapered. Smaller pins go further into the hole than larger ones. Maybe it's the cutter, maybe it's the head itself, or maybe my mill's spindle is bad. I won't jump to any conclusions just yet though. Since I'm already oversized, let's go ahead and try a different boring head. Well, that seems to have solved the problem. A 380 pin slides perfectly through the bore, while a 381 pin doesn't even start. I'd say that's pretty parallel. But more importantly, it means there isn't a problem with my mill. That's a relief. I'll run through the rest of the blocks, chamfer the holes on either side, and we can move on to milling out the pockets. Okay, it seems like there's a lot to these pockets, but really, it's just a bunch of milling. I did, however, put together the coordinates of everything, accounting for the tool radius, so I don't have to do any math on the fly. Making this just a matter of tracing the path in a counterclockwise manner around the perimeter, so tool deflection doesn't cause me to overshoot my dimensions. Then continue the same direction, conventional milling away the middle. So far this is going pretty smoothly. Now to continue a little deeper here in the middle. This will be a bit challenging since this portion of the pocket is deeper than the flutes are long, but I think as long as I'm careful I should be okay. Nice! I guess the flute length was a problem after all. The end mill seemed to be managing just fine, but it wasn't too pleased about the chip buildup at this point. I'm assuming one of those chips got squeezed between the unfluted mill shank and the side of the part, and promptly gave me the middle finger as it left the building. Fortunately, the damage to the part will be cleaned up during the finishing passes, but the bigger problem? I don't have any end mills with longer flutes. And being that it's a Saturday, the earliest I can get replacements is still 2 days away. But I do know a guy. Let me make a call. Remember Craig from my puzzle video? Well, I told him my problem and he came in clutch for me. He gave me a plethora of options to try out. 2 flutes, 3 flutes, 4 flutes, high-speed steel, and carbide. Most of these have longer flutes, but his recommendation was to actually use these shorter flute mills. The shank on these is cut down 15 thou smaller than the cutting diameter to give chip clearance where the flutes aren't. But because the stem is solid closer to the end, the whole thing is a lot more rigid than, say, a fully fluted mill like this. So let's give Craig's recommendation a try. So this is how it's going to go. I finished roughing one pocket and started on the next before, well, this. What's strange is I didn't do anything suddenly. It just gave up. If this is how it's going to be, I'd better change my strategy. I'll switch back to the shorter mills and clear as much of the pockets as I can, while also reducing my cutting depth by half to hopefully get these to last a little longer, and reserving the longer mills for the deeper portions of the pockets. Well, that approach sort of worked. I got all 4 pockets roughed out, and I only broke 2 more end mills. That leaves me 3 tries for the finishing passes on the perimeter of the pockets. I'll give this carbide a go. Well, that went a lot smoother. Maybe I should have been using this guy from the get-go. The surface finish also looks fantastic. With all 4 blocks finish milled, I can work on relieving the material to form this clamping tab. My original plan was to use this little 1/8 inch dude, but as we've learned, if the flutes aren't long enough, that's just not going to pan out too well. So I'm going to jump up to a 3/16, that should be just long enough. Even still, I'm taking this extra slow with just 25 thou deep passes back and forth as I work my way down. That ought to do just fine. And with these tabs cut out, I can come back in here and drill and tap the holes for the set screws. It's honestly just nice to see this part in a different orientation. I don't even want to tell you how long I spent on those pockets. Maybe you can see what I'm thinking here now, but as I tighten the set screw, it deflects the tab down slightly. This will prevent the tip of the grub screw from biting into the jaw faces. Next up, I'll flip this end for end and remove the excess material from the top. I left this long primarily so I wouldn't be partially drilling through an edge. But with these holes finished, I can rough away the bulk of the excess steel. Then switch to the fly cutter for the finishing passes. It's hard to tell, but this cut is just slightly above centerline of the hole, which will prevent the inserts from falling out. Now, just when you thought I was done working on these pockets, there is still just a little more work left to remove these corner bits. But I also have to cut down the outer corners as well. So back on the mill, I'll get the vise mounted on its swivel base, swing it around to 45 degrees, use some angle blocks to indicate it in as accurately as possible, and mount one of the parts. Now I could just come in here and eyeball the cuts to remove the offending material, but I would most likely overcut them in some way, and Daddy don't like that. Instead, I'm going to do my mathematical best to locate all the cuts from this bore. I know the X and Y coordinates of each of the 4 corners when the part is in this position, but when I rotate it 45 degrees, as I did on the mill, these numbers don't do me much good. I could do a lot of trig calculations to figure out the new X and Y coordinates, or I could just do a little matrix algebra. This is a clockwise rotation matrix, and if I plug in my angle of 45 degrees, and then multiply this by a matrix of my original X and Y values, I'll get the new X and Y coordinates. How cool is that? Okay, I admit, this is only faster if you happen to have a graphing calculator like this. But seeing as this is the first time since school that I could actually use matrix algebra, I couldn't resist. With the new coordinates sorted out, I'll use the coax indicator to find the center of the insert bore, and then get to work finishing out the pockets. That math must have come out just right because absolutely no overcuts. Daddy happy. Back at the mill, I'll finish out the angled cuts, removing the outside corners, measuring the progress via the thickness of the remaining web. Okay, for all intents and purposes, these parts are finished. They fit onto the chuck jaws with a very satisfying thunk. And the set screw clamp works perfectly. But you know what would make them a whole lot better? Well, yes, but no, that's not what we're going to do. Let's try some rounded corners instead. And I happen to have the perfect tool for the job. My rotary fixture table. Honestly, a not insignificant motivation for this project was to use this fixture for the first time, so let's give it a spin. To locate the parts, I'll employ the dovetail guides I made as well. Despite my initial efforts, these do have a slight amount of error to them, but as long as I account for this, I should be fine. I think. I'll use a gauge pin offset the specific distance to set the guides for the radius of the rounds I want to cut. Place my part against the guides, clamp it down securely, and then let the table do its magic. Obviously, I used this fixture for some test cuts when I first made it, but I still just love how easy it is to use. The guides and clamps make cycling through the parts super speedy. And the hard stops on either side basically eliminate the possibility of overswinging as I make the passes. I'll likely never make up the 2 months I spent building this fixture, but really, this thing is so awesome, I don't even care. Alright, that's one leg of expedition corner rounding complete. Now to come up with some way to round over these face edges as well. The perfect tool for this would be one of these fancy corner rounding mills, but I thought I'd try to come up with something I already have. So how about a side project? Okay, so what I made here is basically a lathe form tool, but with some clever setup, I can use this in the mill as well. Mounting this in the boring head should work, plus the adjustability will let me dial this into a nice round cutting diameter. But while I sound confident, I'm not entirely sure how well this is going to work. So I think some test cuts would be a wise idea. Yep, I think this is going to work just fine. I'll get a real part back on here, and since I'm still on the rotary fixture plate, I can just run down one edge, sweep the table around the corner, and then continue down the next. And lastly, set the part back up to finish where I left off. I know I go on and on about chamfers, and rounds are pretty nice too, but rounded rounds? I think I'm in love. I still have to round these 45-degree corners as well, so back to the fixture plate for some slight changes in the setup. For one, I need to limit the swing to 45 degrees, which I can do by just moving this bump stop over one hole. Next is to adjust the guides so that the 45-degree corner actually lands on the center line of the table. So I'll hold a gauge pin in the spindle again and set it tangent with the part. Then swing the table 45 degrees and bring the part in to touch the angled face. And to make this repeatable, set the guide against the end of the part. Now I can work through rounding the corners and top edges just like before. Well, I'll be a brown-haired biscuit eater. These look frickin' fantastic. Every corner that might come in contact with snaggy chips is nice and smooth. There is just one issue to address though. These set screws are a bit obscene. Let's take a trip over the set screw shortening machine, shall we? Who doesn't love a perfectly flush set screw? Certainly not me. With that sorted, I just have the final task of making the clamping inserts. Another quickish task for the lathe. The biggest challenge here is getting the diameter just right. I want these to be a half thou larger than the hole for a manageable press fit, but it looks like I'm already getting a half thou taper because of the tailstock. So a couple good whacks will get this guy in line. There we go. All that's left is to finish out the length and ends, and might as well make a set out of copper as well. Okay, let's get these together. Ooh, daddy happy indeed. These are gorgeous. And not only that, they seem to be really solid as well. Let's see how they do in action though. First I'll just do some simple turning on a part to get a decent finish. Now when I flip this, the softer copper shouldn't mar the nice aluminum surface. Hey, I lined that up pretty perfectly. But more importantly, not a mark to be seen. Alright, I think this might go down in history as the most elaborate set of softjaws ever. I spent way more time making these than I even care to admit on camera. But they were a lot of fun to make. Except for the pocket milling, that sucked. Everything else though, totally worth it. I think these jaws have earned a permanent home on the chuck, because now I can be certain that my precious parts will indeed be protected. As always, thanks for watching, and see you next time.